gold bars, chocolate bars, soap bars, balance beam bars, counters in bars, or it's a bar counter, yes, and still bars. But today, we're gonna be talking about bar graphs. Hi again, it's me, Teacher Faith, and we will have to know about these following objectives. Number one, at the end of this video, we'll be able to identify the parts of a bar graph and types of bar graphs. Number two, be aware of misleading bar graphs. And three, analyze bar graphs. So here are the parts of a bar graph. This topmost one is what we call the title. Here on below on the horizontal part, we have this x-axis label, which provides the general description of what these categories are all about. Then we have here the y-axis label. This gives you the description of what these scales or these numbers are all about. And this part, we have what we call the key that gives a color coding of what these bars or the data means. So by comparing the length of the bar to the scale, you can estimate the values the bar represents. So we have to take note that the bottom of the bar always sides with the categories. You cannot place the bottom of the bar here on the scale, as the end of the bars determines how many they are according to the scale. There are two types of bar graph. First, we have the column type or the vertical bar graphs, which goes upward. Then we have the bar type, the horizontal bar graph, which goes to the right. So, as I explore in the Microsoft Word application, there are many types of vertical bar graphs. These are clustered column, stacked column, in which instead of putting the categories one by one, it is stacked all together, okay, and gives the total amount in a certain category. And the 100 stack column gives a comparison of how many percent there are in a certain category. We have 3D for three-dimensional, 3D clustered column. So these are almost identical, but the series is just placed at the back, while here the series is placed on the sides. We have the 3D stack column, the 3D type of this one, and we have the 3D stack column, the 3D type of this one. For the types of horizontal bar graphs, it goes to the side. So we have the following: clustered bar, stacked bar, and 100% stack column. So likewise, they are converted into their corresponding 3Ds. But as time goes by, different designs had come up as the creativity of people are developing. Colors and other aesthetic figures and icons develop to make the graph more pleasing to the eyes. So we're gonna be aware of these following bar graphs. So we have here, this is a truncated bar graph because there is no zero base. So this is accurate 43 and 39 but misleading, as should the baseline should start at 0, not 37. So the difference between 43 and 39 is just small, but if we look upon the graph, we will first perceive it to have a great gap. So it is accurate but misleading. On the other hand, okay, these graphics are accurate but misleading, as yes, it starts with 0, but then if we look up on the graph, they have very little difference. So what is recommended when there are more data here below than which is which shows the difference between a 39 and 43. So let us put an emphasis here at the top by simply having a cut here below, and it is recommended that we indicate a y-axis break. Okay, so you can start with here 0, and you can start with 37, 38, 39. You can represent the break within this one or within that one if there is in the middle, and we have also that one. Of course, bar graphs are very misleading when there is no scale. So we have 120 and with 50, there are less difference, but if we put here 120 and 150, there are more difference. So it is very recommended that there should be a scale here along the y-axis. Another types of misleading bar graph, we have the incorrect 3D. So which is which? Is the scale will be referred to this blue line or this red line? Okay, on the other hand, having a 3D bar graph that is very extreme in rotating the figures would cause um, misleading on the first perspective. So the blue column in the front appears larger than the green column, okay, due to the perspective. But if we look upon the line here, they have the same value, okay. Then when scaling in 3 dimensions, the effect of the change is cube. So we have this one. If we enlarge this cube, okay, so it is never recommended to enlarge a cube when it comes to bar graph, but rather let's just stack it up. Okay, so let's practice. So example number 1, employee discrimination complaints from year 2006 to 2011. A national corporation made a bar graph to show the number of discrimination complaints by the employees during a 6-year period. So our question number 1 is, how many more complaints were made in 2010 than in 2009? So this is 2010, 2009. So this is approximately, okay, so we have here 32. And then we have the line here going to there. So we have 20. So that means there are 12 more complaints made in 2010 than 2009 as we subtract 32 by 20. Number 2. To the nearest 10, how many employee discrimination complaints were there in 2006 and 2007? So 2006 has 22 and 2007 has 27. So altogether in 2006 and 2007, we add 22 plus 27 equals 49. Since we are trying to find the nearest 10, that is approximately 50. There are approximately 50 employee discrimination complaints in years 2006 and 2010. Number 3. To the nearest 5. How many more complaints were there in 2011 than in 2006? So this is 2006 we have already. So 2011 we have at around 35, 36, we have 38. So how many more complaints? That means we subtract 38 from 22. 38 minus 22 equals 16, but since we are being asked to the nearest 5, we have approximately 15. There are approximately 15 employee discrimination complaints in 2011 than in 2006. Number 4. By what percent did the number of complaints decrease from 2008 to 2009? So we already have here 2009. Let's put 2008 at 25. So 25 minus 20 divided by 25. Okay, we have it here. We use 25 as the uh, original amount decreased from 2008, so which is 25. 25 minus 20 gives us 5 divided by 20, 0.25, and that gives us 25%. The number of discrimination complaints decreased from 2008 to 2009 by 25%. We may proceed to our next graph. Bar graph number 2, cost of movie making. So we have already here two types of series. So our first color here, which is a dark plum, okay, that refers to box office receipts. While here we have the orange, so that refers to cost. We have film A, B, C, D, and the scale is by 20s. Okay, so this is 20, 40, 60, but it says here this is dollars in millions. So this is $20 million, $40 million, and $60 million. A studio released 4 films in a year. So as you can see here on the graph, that is film A, B, C, and D. The graph compares the cost of making each movie to its box office receipts, or what we call ticket sales. Question number 1. Film B's cost is what percent of its box office receipts? So this, we will focus only on Film B. So the cost is $25 million, while the box office receipts or ticket sales, we have $65 million. What percent Film B's cost to its box office receipts? So we have 25 divided by 65. Okay, so that it gives us 0.3846, or move 2 decimal places to the right, we have 38.46%. So Film B's cost is only 38.46% of its box office receipts. Question number 2. How much more did it cost to make Film A than Film B? So we will only focus on Film A and Film B, but we will narrow it down only to cost. We will disregard the box office receipts. So we have 85, 85 and 25. So we will deduct 85 minus 25 is equal to 60. So it costs $60 million more to make Film A than Film B. Number 3, which film made the greatest amount in profit? So the hint is there. The profit is equal to receipt minus cost. Okay, so we have box office receipt minus cost. We'll move here one by one. On film A, we have the 130 million for the box office receipt minus, okay, 85. But before that, we are going to complete all of them so that we can compute all together. For the film C, we have 40, 60, 90, approximately 92. Okay, then we have here 65. Okay, so 130 minus 85 will give us a profit of $45 million. On film B, 65 minus 25, it gives us $40 million of profit. Here we have film C, the office receipts is less than the cost, Okay, so they costed more than what they had gained, so that would result to a loss of $20 million. Okay, or we can put it on negative 20. Then 92 minus 65, the profit is 27 million. So which film made the greatest amount in profit? We have film A. Film A made the greatest amount in profit. Last question in this table. Film C cost was what percent of its box office receipt? Okay, so the cost is what percent of its box office receipt. So since they had a loss, how much more did they spend than they gained? So 60 divided by 40. So we have 1.5, or that is to that converts to 150%. So film C's cost was 150% of its box office receipt. Okay, so now you try. Here we have items sold for the week of September 20. Let's proceed to our question number 1. Approximately how many t-shirts were sold than books and toys combined? Okay, so these items sold games, toys, books, movies, t-shirts. So these are more on the hobbies of our high school students. Okay, assuming. Okay, do you like games? Do you like toys? Books, movies, t-shirt? Okay, I bet each one likes at least one of this. Okay, so let's proceed. So, how many t-shirts? Let's go to t-shirts first. 100. So this is approximately 110. So because it is between 100 and 120. For the books, okay? So since we can't accurately put, as there is no minor scale, so we can make an estimation of 40, just 40. Then for the toys, since this is between 20 and 40, we can make an estimation of approximately 30. So, how many t-shirts were sold than books and toys combined? So, we are going to subtract. So, 110 minus, we're going to combine this 30 and 40, toys and books. So, that gives us 70. 110 minus 70 gives us approximately 40. So our answer is A, 40. Question number 2. One half of the games sold during the week of September 20 were on sale for $16. The rest sold for the full price of $24. Approximately how much money did the store take in for games sold during the week of September 20? So first, let us take a look upon how many. Okay, so we have 40 and 60. This is between 40 and 60. So approximately there is 50. Now, we're going to half the 50. Okay, so 25 and 25. So 25 belongs to $16, while the rest of the 25 for the full price of $24. 25 times $16 gives us $400, while $25 times 24 gives us $600. So 400 plus $600 gives us $1,000. So our answer is letter D. Our last graph, Echo Canyon camping permits. So this is a clustered column type of a bar graph in which the yellow here represents 2-day camping permits, while the pink here represents 5-day camping permits. Question number 1. In May, what was the ratio of the number of 2-day permits to the number of 5-day permits? So we will only focus on May, okay, and disregard first the rest. So here are our options. We have 2 is to 5, 3 is to 17, 4 is 14 is to 3, and 14 is to 17. Okay, so let us first look how many we have here. 70, And for the 5-day permits, we have 15. So in order to find the ratio, we have the 2-day over 5-day, which we already know that our 2-day is 70 and our 5-day is 15. So since this is ratio, we are not going to divide it, but rather just look for the greatest common factor and divide it on the corresponding numerator and denominator. 70, okay, the greatest common factor of 70 and 15 is 5. So 70 divided by 5 and 15 divided by 5, which gives us 70 divided by 5 is 14, 15 divided by 5 is 3. So our answer is letter C. 14 is to 3. Number 2, which month was there a total of 80 permits used? So we have June, July, August, and September. So since we're only looking for June, July, August, and September, we don't have to waste our time trying to figure out the values on April and May. So in June, we have 70 and we have 30. So total of 100, so no, it can't be June. Here on July and August, they already have 80. Okay, so that means it also cannot be July and August, as to add the 40 and 30 will exceed their values more than 80. And September, we have 60 and 20, which if we are going to get their sum, it is 80 permits used. That means our answer is September, letter D. So I believe now you already know how to analyze bar graphs and have known the different types of graph and be aware of the different misleading bar graphs in case you'll encounter them someday. So, congratulations! You now have completed this lesson. You can be able to understand better our next lesson, line graphs. But before I end this video, let me share you an inspirational quote and a Bible verse. As our goal is to reach up high, like the bar graphs going high, let us remember that both we have a vertical and our horizontal bar graph will give us Christ as our ultimate goal. And Philippians 4:13 says, I can do all things through Christ or through him who strengthens me. Have a good day everyone and see you on the next video.